So over the weekend, I was hacking on my Remix side project. It's this app I'm using to track my lifts at the gym. And I added a little chart here using D3 to kind of visualize my lifts over time. And I started out with kind of a pre-built chart library, but eventually really wanted to just use D3 because D3 is low level. I can make it do whatever I want. And so I wanted to show you kind of what I ended up with. We're going to rebuild this chart from scratch right now. So I've got my charting component right here. And if we switch tabs, we'll see there's nothing being rendered. The only thing we're doing is passing in my data, just doing a little bit of manipulation to get the actual data I want. And then we're rendering this inner chart with an SVG. And if I go ahead and add background gray at 100, we'll see that SVG being rendered right here. Now, again, if I kind of quickly paste in the first version of this that I did over the weekend, it's using this library plot. This is actually something new I hadn't tried before. It's from the folks who made D3, and it's meant to be kind of abstraction layer on top of D3 to make common charts a little bit easier. And you'll see here it does a pretty good job. We could tweak these colors and tweak the axes, but I really wanted more control. I wanted that zebra striping that I had, and I also wanted to be able to animate everything with framer motion. So you'll see here a lot of libraries do this sort of thing where you call plot.plot. You get this chart object, you specify all the things you want, and then you append it. This is kind of this imperative API that, again, a lot of these libraries use to manipulate the DOM. But what we're going to see is with D3, we're going to be able to use React to render SVG elements and then just set their properties using D3. That's going to keep us at that low level so we can mix and mingle all sorts of libraries that we want. So let's go ahead and undo this and just get our gray SVG back. And let's start working on this thing. And we're going to start by rendering a line because without a line, we don't really have a line chart. So let's just go ahead and start by pasting in some dummy data here. And then we're going to use the d3.line method to give us a line generator. And then we can use this to generate a path for our dummy data. So if we capture this kind of in a result variable and we go ahead and log this out, then if we come over here, we'll see that we get this funny looking string. And this is what we're going to pass into a path element for its D attribute, just like this. So this looks kind of funny. This is because we want the fill to be none. And then if we make the stroke black, we'll see that we're drawing a path here in SVG. And so if you've never seen path before, this is kind of the syntax. It has this D attribute, and this is basically a series of instructions on how to draw this line based on the data. So that's kind of cool. And if we come here, and instead of making the stroke black, we make this current color. Well, now we can come out to kind of where we're rendering this chart, which is in the index file. You can see right here is the chart. And we can do something like text blue 500, and we'll see the path kind of inherits that. So if you've ever worked with SVGs before, this is how you can use Tailwind to style SVGs. Again, we're rendering SVGs here. It's the same exact thing. It composes with the stuff we're already using, no problem. And so we can kind of see here, let's go ahead and delete this, and we'll rename this to D since it's the D attribute of the path. We can kind of add more data points here, 120. To, 50. And we're going to keep adding points to this. So the way a line works by default is using these X, Y pairs. So this first point is X of 0 and a Y of 10, an X of 5 and a Y of 50. Now, again, if you've never worked with SVG before, this might seem strange, right? Because the second point has a Y value of 50, but it's below the first point. And that's because by default, SVG starts out at the origin here. 0, 0 is in the top left corner. So these are actually extending downwards, which is not really how we think of this data. The conventional way to fix this is to use a Y accessor on our line. So again, by default, this line function is going to look at the second element of the tuple we pass it for the Y value, but we can change what it uses for the Y value with this .y property. So for each data it receives, again, by default, this is kind of the default Y accessor, but instead of going down 10 pixels, we really want to start at 10 pixels from the bottom. Well, you'll see here that we're passing in the width and height, and this is what we're using for our SVG's view box. And this is coming from this div right here, which is being used by this ref. And we're using that with useMeasure, which is a hook to calculate this area. Usually we work with pixels in SVG, so this is a nice, easy way to get the pixels. And so if we just were to take the height and then subtract it, this kind of inverts the chart. And now we see something that looks more like what we would expect. So the first point is an X of 0 and a Y of 10, then 550, and then 1575. So if we were to add like 140 and then go up to 100, we should see this higher, and we do. So this inverting of the Y-axis is usually the conventional way to handle this in D3. Okay, next, it'd be nice if the chart actually filled our entire SVG. Right now, it's actually using these as the pixel values. So this is our data, and we're saying data point is 0, 10. It's actually just using 10 for the pixel value, 50 for the pixel value, and so on. But we want to map this so that it takes up the entire space of our SVG. And for that, we're going to use a scale. So let's start with the X direction, so it stretches out the whole width. And so we want an X scale. And the way we create a scale with D3 is d3.scaleLinear. And now scales take a domain and a range. And the domain is the min and max of our input values. And then the range is the min and max of our output values. Well, the range is easy because we want it to go from 0 all the way to the full width. And again, we're passing in the width right here. So this is just going to be 0, width. And for the domain, we want basically an array with min and max of our X values. So our X values are here, 0, 5, 15, all this stuff. So we could just plug these in, 0, 140. And now we have a scale. And then we want to tell our line to use this scale. So we'll come here and create a .x property. And we're going to tell our line for each data point, we want to go ahead and return the X value. This is kind of the default. So if we save this, we shouldn't see any change. But if we were to scale this by our new X scale, now look at that. We see the line stretches all the way out. And a lot of times you'll see this called X, but it's a little terse. So let's just call this X scale just for clarity's sake right now. So this is kind of how we can tweak the values we get out of this line function. We're just telling it, go ahead and scale each of the X values. And now, instead of hard coding the values in right here, it'd be nice if we could dynamically calculate them. So if the data changes, the scale updates. So we could use min and max here, but D3 has a handy function called D3 extent. And this basically does the work for us. It takes in an array of numbers and returns a tuple with the min and the max. So if we pass in our dummy data, and then we just map each element to the X value, which is the first element of the array, then we just saw it flicker, it refreshed, and nothing changes. So now if we were to add another element here at 180 and bring this back down to say 50, we see that new element and everything fits in our SVG perfectly. So now we have kind of a dynamic X scale. Let's go ahead and make a Y scale. And we're going to do the same thing. We'll calculate the extent of all the Y values. So we'll change this to 1. And then our range is going to be 0 to the height. And this is going to make the line stretch to fill the whole height of the SVG. So let's come and actually just replace this with Y scale of the Y value. And we'll see here that now it's filling the space, but we've kind of inverted it again. So the conventional way to solve this is if we just actually flip this from 0, height to height, 0. We'll get that flipped. And now we see the data we expect, right? The first value has a Y value of 10, then it goes up to 50, then it goes to 75 and 100, and then back down to 10. So this scale is a really easy way to kind of fix that origin problem. This way our line is only concerned with scaling the right pieces of data here, but everything works out. And now, even if we were to remove some elements from our data set, the line chart stays scaled. And so this is kind of a really nice way to get this set up. We have our SVG with the width and height. If we go back out to our index page, this is nice because, we can add some margin here using Tailwind. It'll push the chart down. We can add some padding of 6. It'll squeeze the chart. Everything just kind of works when you set it up like this. So this is a pretty good way to just stick with the conventions. And once you get it set up, you don't really have to think about it. Okay, next you can see our lines are getting a little bit cut off here. That's because the stroke is going all the way to the edge of our SVG, just because we've set this up to kind of expand all the way. So the usual way to solve this is with kind of a margin convention. We can just create a margin object. And let's start with like 20 pixels on the top, right, bottom, and left. And this is the beautiful thing about scales, right? Scales just map an input, a domain, to a range. So if we count for the margin in our range, well, we can fix this issue and buy us some breathing room. So on the X side, instead of going basically from the edge here to here, we want to account for the margin on the left and then go to this width right here minus the margin on the right. So instead of 0, we'll use margin.left, and that should nudge this over by 20 pixels, and then width minus margin.right, and that'll nudge that over. And then same here, instead of starting at 0, which is going to be up here, we want to start at margin.top. That should nudge that down. And then height minus margin.bottom. And so now we have some breathing room for axes and scales. We can change these kind of as we build out our chart and decide how much margin we need. Okay, let's come up and instead of using our dummy data, we'll see we're passing in the data from my actual application here. If we go ahead and log this, we'll see it's an array of objects with a date property, which is kind of a JavaScript date object, and the estimated max, which is what we want to put on the y-axis. So when working with dates, it's good to parse it into an actual object before we start graphing it. You'll see up here I'm doing just that with parse ISO, which is a function I'm getting straight here from date-fns. So this is coming from the server, these entries, and then I'm kind of massaging them into this data structure. That's the usual way to do it. But if we wanted to replace this dummy data with our actual data, we can comment out dummy data. And then for the domain here, we're going to look at our data. And instead of taking the first element, because it's not a tuple, it's an object, so we're just going to grab d.date. And then same thing down here, we'll say data, and we'll map this to d.estimatedMax. And then when we want to scale these up, for each piece of data, the x should apply to d.date, the y to d.estimatedMax, and then to calculate our path, we'll just pass in our data. And there we go. We see our actual data being processed right here. So that's pretty cool. Let's come up and delete this. And this is the basics of our line chart. You can see here, if I go around to these other exercises, we'll see that data changing. So already this is, reactive and everything. If I change the width, we'll see React use measure right here is recalculating the bounds. We're passing in the new width and height of that bounds. So everything is looking like it's off to a good start here. Now, if we come look at kind of what I ended up with here in production, we'll see we have these ticks along the side of the y-axis, and then we have the months along the x. So next, let's work on these ticks on the y-axis right here. And these are going to come from our y scale. We've already set this up with a domain and range. So if we come back, pop open the console, we'll see that scales have this really helpful property called ticks. And we can call that and log it to the console. And we'll see we get an array of numbers here. It does a job of rounding these to nice numbers in a way that covers the extent of our data on the y-axis. So what we can do is use yscale.ticks right here in our JSX, yscale.ticks. Go ahead and map over these, and for each one, we'll return an SVG text element. And each one of these is a max, so we'll use that to go ahead and render that label. Now let's go ahead and give this a key of max. And you can barely see they're right up there. That's because they're positioned again at 0, 0. So if we were to push them down by like 100 pixels, we'll see them all stacked up right there. But we don't want to push each one down by 100 pixels. We want to push it down by where it lands on the scale. Well, we have a Y scale, don't we? So we can just scale each max and check that out. Pretty neat. We can position it exactly where it falls on the chart. Now let's add a class name here. We'll make these smaller. And SVG text takes a fill property. So if I were to use fill blue, we'll see them appear as blue, but we can just make these current color. So we can use something like text gray 400. And if we go ahead and drop the background right here on our SVG, we'll see we have some ticks. Now, this is where the margin comes in. Let's add a little bit more margin to our actual chart, push it over, make some room for that. And let's also add a little line by each tick. So we can render a line right here. Now lines take an x1, y1 and an x2, y2 for the 2 points that define the line, and these all start off as 0. So if we were to define, x2 is 10 and y2 is 10, give this a stroke of black, and we need to wrap this inside of a fragment. Then we should see some little lines here appearing in our SVG. But we don't want each line to be at 10. We want it to be at the Y scale of our max. So if we grab this, paste this in here, we see we're getting closer, but Y1 is still at 0. So let's just copy this and set this for Y1. And look at that. We've got a tick next to each max. So now we can kind of finesse this. Instead of x1 starting at 0, let's move this over. We can start this at something like 20 and then make it go to 25 or 30. Let's make our text a little bit smaller. I think XS is 12 pixels. We can make it 10 pixels. We can also make the stroke here the current color. And then let's create a wrapping group element so that we can put class name of text gray 400 on this. We'll remove it from here, and that should make both of these gray. And we'll also move the key right up here. So G in SVG is kind of like a div in HTML. It just lets us group related things. And now we can see the color is applying. Now we'll see the text kind of starts off as a baseline right where the tick is. The tick is basically perfectly where our scale says it should be. We can fix this with an alignment baseline property of middle. And that looks a lot better. Let's go ahead and push this over a little bit more. 22. And now you can kind of see how you can build your own tick set just by rendering ticks. And we have complete control over this. So one cool thing we can do to clean this up is you'll see we're basically moving each text node and each line down by Y scale of max. We're doing that here, here, and here. But we can just set a transform property on our group of translate, and we want to move it over nothing. So we want to start on the left-hand side, but we want to move it down by Y scale of max. So this is basically going to push each G down by what we need, which means we should be able to get rid of this, this, and this. And we're kind of back to where we started, except, conceptually the group, if we were to look at this, the group is what has the transform. And so now the group is starting exactly where it needs to. And then kind of anything we render inside of this group is going to be at the correct position. So that's another handy little trick. And clean this up just a little bit more. So what if we wanted these lines to extend actually all the way across? Well, instead of going from 22 to 32, we could just make this go all the way the full width. And then we'll subtract the margin.right. And to start it off, we can start it off exactly where our line starts with margin.left. And we can make these dotted with stroke dash array. This is going to let us add dots or dashes. You can see kind of as we change this, we get to change what this looks like. We could even make this even smaller if we wanted. Or we could keep this at 1. And this actually takes, we can just make this a string. It takes an array where we can add some more space in between each dot. So again, this is kind of why I like this technique, because we just have total control over how these things are rendered. And hopefully you can see just, how far you can go with customizing this. So we can bring the left margin over just a little bit more, get it a little bit closer to our labels. And again, everything is going to work here. If we scale this, everything is going to stay exactly kind of relative to how we've set this up. And we can try this out. If we change the exercise, all of this is changing. Now you'll see there's quite a lot of ticks right here. By default, this function is going to kind of do its best to guesstimate how many ticks you need. You can throw in a number here to try to reduce it. And so it's going to do its best to get as close to 5 here. And so we see that it looks a little bit nicer. It's always good to test your data visualizations, on different data sets and make sure it accommodates it. So I kind of like that, having fewer numbers just like that. It's pretty easy to read. Okay, so I think our Y scale is looking pretty good. Here is our line. Let's go ahead and do exactly the same thing for our X scale. So we're going to grab our X scale. Let's start with the default number of ticks. And each one of these is a date. So if we were to create a text object and render the date, let's see what we get. Okay, we can see some new data here. Let's go ahead and do the same strategy where we wrap this in a group. And we're going to transform this as well. But we're drawing the ticks here on the x-axis, right? If we pop over to what I ended up with, we're going to have them down here. So instead of moving them over by 0 and down by the Y scale, we want to move them over by the X scale of the current date, which is coming from our loop. And then let's just leave them at 0 for now and see what we get. So that's kind of spacing them out a little bit. If we add some values, we'll see this puts it down. So let's go ahead and push it down by the total height, which we have as height. So these are looking kind of funny. These are actually numbers. If I copy one of these and paste them, these are seconds from the epoch. So we'll see that our X scale is operating on dates, and we're using a linear scale. And what this is going to do is turn this basically into a date. If you've ever created a new date using seconds from the epoch, you can basically represent any date by a single number. But fortunately, D3 has a time scale we can use with scale time. And then we're going to get this error because we're trying to render an object into JSX. But if we go ahead and log xscale.ticks and take a look at what this is, well, we're going to see up here, we get an array of ticks, which are each date objects. So this means when we actually render them down here, we can use date-fns. So we'll grab format from date-fns and pass in this date. And now we can just render anything we want. Look at that. We can see the date. So let's clean this up. We'll make a little bit more room. Instead of the full height, let's come back up about 5 pixels. On text here, we'll make this text 10 pixels. We'll come back maybe a little bit more, 10 from the bottom, so we can see those descenders. And we could add the date in like this. Let's also pass in 5 for the ticks, so we just get fewer ticks. And look at that. Pretty neat, right? You can do, if you wanted something like this. This is why, again, I love this. We have complete control over here. We're just working with JavaScript date objects and our own date formatting library. Pretty cool. Let's go ahead and make the fill current color and then slap a class name of text gray 400 on the group. And let's go ahead and add a key of the date to this group here. We'll switch this back to the short month name plus the day. And this is looking pretty good. Now, we can see D3 here is picking like March 1st, April 1st, and May 1st for us, but we don't, again, really have a ton of control over these ticks. There's a lot of logic in this function to try to help us with all sorts of different data sets. But if we look at what I ended up with, I kind of wanted this treatment where, first of all, we go to the beginning of the first month and the end of the last month. So we're seeing full months here. And then we have this zebra shading with the text kind of centered in each month. And so again, that's just what I wanted. Because we're in this low level, we can do whatever we want. So let's work on that. So first, we want to extend the domain of our data set to not just be the first date and the last date. We want to actually go to the end of the month. And you can see here, our most recent entry is May 22nd. That's going to correspond to this last point. And if we look at our first, it's February 8th. We want this to be on February 1st. So let's come up to our X scale. And instead of just calculating the extent of all these dates, let's delete this. And we want to do this ourselves. We'll grab the earliest date. This date is already sorted, so it's going to be this. And then we'll grab the last date, which will be data.length -1, and then the date property. So this is basically what we were already doing. We can save this and see it doesn't change. I'm actually trying to get better about using this new at method. So, this is kind of the old school way of getting the last element of an array, but we have this at method now, which we can pass in -1. And again, if I save this, everything still works. That's pretty nifty. So I'm trying to get better about using at. So let's use that right here as well. Data.at0. But then we want to go to the first of month here. So we can use start of month from date-fns. And pass in this date object right here. And that should bump us to February 1st. Look at that. Pretty cool. Let's add a little bit more margin bottom to make room for these labels. And let's go to the end of month from date-fns, just like this. And that should get us all the way to May 31st. So this is pretty cool. I like this. Now let's work on the actual shading. So we basically want to add a rectangle for each month here in the x-axis. So we're actually going to pull this out into a start day variable. And let's get end day, which will be this. We'll go ahead and replace this with start day, end day, save it, make sure we didn't mess anything up. And then we can calculate the months between these 2 days using each month of interval. Another handy function from date-fns, which takes a start as our start day and an end as our end day. So if we log out these months, come over and take a look, then we'll see we've got February 1st, March 1st, April 1st, and May 1st. That's pretty cool. So that means down here in our x-axis, these I meant to call x-axis and y-axis. Instead of mapping over the ticks, let's just map over the months. And I'll just rename this to month. It's really the first day of the month, right? And in this case, we're getting the same thing, but now we basically have this guaranteed where we're starting at the beginning of the month with the earliest entry and going to the end of the month with the last entry. So this one only has 1 month. Here we see 3 months, and here we see 4. Now what we can do is add a rectangle for each one of these. And rectangles have a width. Let's just start off as 50. And a height, and they take in a fill. Let's make it black, just to kind of see what we're working with. And we can see they're starting out down here thanks to this transform on our group. So this means if we were to make the rectangles taller, they're actually kind of extending downward here because this transform is making this group start all the way at the bottom. We want to fill this whole thing. So instead of kind of transforming the group down to the height, let's just start this off at 0 for now. And now we see our rectangles kind of starting from the top. And this will help us get this working. Now we still want these texts to be down below. So let's make their y value the height. And that'll put them back down there. And now we can work on getting these rectangles correct. So the height, we should use the height of the chart minus margin.bottom. Let's use that for now. And then the width, we actually want the width to fill in the entire month, right? Instead of just being hard-coded to 50. Well, the width of a month can change based on how many days are in it, but we know we can get the position of the first day of the month like this. So if we make this an expression, and then we grab kind of the beginning position of the month, this would give us the left-hand side. And then what would give us the right-hand side? Well, the end of the month, right? So we can say, let's go ahead and get the end of month for this current day we're on. And then let's scale this with X scale and then subtract the beginning of the month. And look at that. Pretty awesome. We get to use date-fns and our D3 scale to make sure this width matches just right. And if we only wanted to render each other one to kind of get the zebra treatment, let's grab the index and we'll just say if the index mod 2 is equal to 0, then let's go ahead and render a rectangle. And if we want to start shading at the first one, the even ones, we can just say when it equals 1. Now let's make this fill current color, and we'll make the class name here text gray 100, so it's a little bit softer. Look at that, we've got the zebra treatment for the months. Now, right now, our x-axis is rendering on top of our y-axis and our path. All we got to do is move this down. You just want to rely on the sort order in SVG when doing this stuff. So if we just rearrange these, look at that. Zebra behind the axis and the path, pretty sweet. And now, finally, we don't want to render the day, so let's take this off of our date-fns. And we want to center these, so we want to move each month over by half of the width of the rectangle. Well, we've got the width of the rectangle right here, so let's grab this. Let's add an X property to our text, but instead of sliding it all the way over, we want to divide that right in half, just like that. We need a few more pixels here for the descender, so let's get 5 off of the height. And then to actually center SVG text, because right now it's kind of left aligned, we're going to use text anchor equals middle. And now these are perfectly centered within each month. So again, really cool use of combining date-fns, D3, Tailwind here to achieve exactly the look that we want. Now, if we come and take a look at kind of where I ended up, it looks like the path, the stroke width of our path is a little bit thicker, so we can make this a stroke width of 2. I like that. And then let's add these circles in at each data point. So for this one, we should be able to circles, iterate over each element of our data. So we'll map each data and we'll return a circle element. Circles have a radius. We'll give it a radius of 5 pixels. We'll see these are all rendering up here in the top left. They also have a CX for the X position of the center and a CY. CX is going to be our X scale of our d.date, and CY should be our Y scale of our d.estimated max. Pretty awesome. Let's go ahead and key this by d.date, and we can make this a fill of current color so it inherits the blue from the parent. And for one last little detail here, we can make the stroke white and stroke width of 2. Gives us this nice little treatment where we have kind of the circles around here. Makes it look like they're kind of floating on the line. But you'll see because of our zebra shading, we get this strange treatment. So we really want to conditionally make the stroke either white or gray 100 based on whether the data point lies in an even or an odd month. So let's make stroke an expression, and we want to find the index of months that our current date is in. So we can say months.findIndex, and this takes the current month, and we can use isSameMonth, again from date-fns, to check this month against the current date that we're iterating over. And then we'll take that modulo 2, check if it's equal to 1. If it is, we're going to use the gray color. Otherwise, we'll use the white color. And there we can see this kind of default gray. Our gray is actually this. There's ways to get Tailwind into our JavaScript, which I did in my project, but just for the sake of this video, it's this hex code right here. And now we can see, look at that, all the points in March are gray, everything in April is white. Nice little detail there. Again, super easy just because of how composable all this stuff is. So this is basically where I ended up. Let me show you one more thing. Let's come here to our line. Make this a motion.path, which I'll import from Framer Motion. Save that, everything renders as before, but now we can say initial path length is 0 and animate path length is 1. Look at that. We've got a little animation on our path. Let's go ahead and say transition duration should be 1. Pretty cool. Let's make this a type spring. Maybe make this 1.5. And that's pretty cool. If we wanted this to reanimate each time, we could go back to our index and give our chart a key of exercise ID. And that'll basically unmount and remount this chart each time a new exercise is chosen. So that's pretty cool. We can even come to our circles and make them a motion.circle and say initial opacity of 0, animate opacity of 1. And if we give this a duration of 0.5 and this a delay of 0.5, we kind of have this fun effect. Maybe this is type spring, duration of 1. That's kind of fun. We could even use the index here and give this a delay of 0.1 times the index. Maybe bring this down to 0.5. It's kind of neat. We can even make these scale 0 and go up to scale 1. Now they kind of fade in, maybe tighten this up a little bit. You could even animate our other values. So what if we started these all off with a CY and then went to a CY of our scale value? And maybe this is height minus margin.bottom. Isn't this cool? You can basically animate any property you want on these things. I mean, you can go crazy here. Let's go ahead and get rid of these. For now, we'll put this back static. We'll get rid of the delay. But you can really do whatever you want here. This is kind of what I ended up with in my app just to feel it out. And even the drawing, I'm actually going to go back to the index and get rid of this key on the chart. I kind of like that when you first come to an exercise, it draws it, but then as you tab between them, it's really quick. You kind of see that behavior on like the fitness app on iOS. When you go to look at your different days, the rings will animate, but as you start swiping between them, it kind of won't, just to reduce the motion. But you could make the bars fade in or grow up. You could make these lines go out, and you could even animate the values between the different charts. So if you wanted to animate the axes and kind of zoom the weights as you go between the different exercises, you can do whatever you want here. So I just thought this was such a cool example illustrating kind of the power of low-level libraries. Once you get comfortable with them, just being able to do whatever you want with them, literally whatever you want. That's what I love about D3. It is a little intimidating the first time you see it used, but honestly, for me, a lot of the hardest parts of working with D3 are ideas like its selections, like D3 select and appending to things. All of that is because D3 was created to work basically in any environment. So it needed a way to be able to render to the screen, to append SVG and G and path elements to the screen, to be able to update them or remove them when things change. But when we're in React, we already have a way to render and update elements from the screen. We can just use JSX. So the fact that we can use JSX means that we're now at a level where we're totally composable with every feature of React, including libraries that let us do things like render these motion elements. And so this is all going to work. We're basically just using D3 now for what it's best at, which is calculating the line path here or calculating scales, these little handy utilities that you get pretty comfortable with pretty quick. Just like in my video from a few weeks ago on date-fns, you start to just know what you need to reach for. And it's really nice to have this tool belt of small utility libraries that you can use to build exactly the experience you want. Of course, it's not as fast as using a pre-built charting library, but when I'm working on my projects, especially my side projects, but even projects for other people, I like getting all of these details right, and I like using tools that let me get those details right. I never like feeling limited by the tools I'm using. That's why I like Tailwind. That's why I like D3, date-fns, and even React. React lets me do all of that in all of these UIs I built as well. So I thought this was a really cool demonstration of these technologies coming together. If you've never built anything with D3 before, give it a shot. Hopefully now it feels like maybe less intimidating. You should feel a little bit more comfortable with just the basic ideas behind scales and lines. There's tons of examples from the community. I'll link some of them in the description because it's pretty inspiring to see what people have made with D3. But for this, that's basically where I ended up. It's pretty neat. And I also just wanted to take a minute here to say thanks so much for everyone watching. I just noticed my channel crossed 10,000 subscribers, which is really awesome. Makes me motivated to keep going. I never run ads on this channel and I never will, but I would like to figure out kind of how to make this more sustainable in the long term. So right now, me and my friend Ryan are working on a course where we're going to be talking about stuff just like this, focused on framer motion. So if this is your first time seeing framer motion, to do things like animate the path of a line or an icon, you can draw icons with it. You can make things scale in and bounce. You can do all sorts of cool stuff. We're working on a course where we're going to build 8 components that are really detailed from really cool apps and websites like Stripe and Things and Linear. And we're working on that now. So if you do want to kind of support the channel, check out the description for a link to an email sign up where you can just sign up and hear about the work that we're doing. I'd really appreciate that. Otherwise, thanks again just for watching and just giving me your time and interacting with me in the comments. I really love hearing what you guys have to say about this. It guides a lot of what kind of content I produce here. But that's it for me today. Hope you learned a thing or two and enjoyed that. Otherwise, I'll see you in the next one. Bye-bye.